Okay, so this next section, 9.2, is regarding general and particular separable differential equations. So just a warning, this is going to be a really long video because I want to review integrating different kinds of functions and how to write it. This is always a free response question that's usually worth 5 points, and the AP is very picky on what you need to show in order to get each of those points. So like if you didn't show that you separated the x and the y, you wouldn't get any of the 5 points, even if your answer was correct. So I want to go over that as well as some other notation that might come up and things like that. These are also a good review of all of your integral functions, and it can be multiple choice and free response as well. All right. So if you want to fast forward, you're welcome to. I thought having more examples would be better than less examples. So first of all, a differential equation, there is literally a whole entire class in college called differential equations, DiffEQ. And if you're an engineer major or a math major, then you'll have to take this class. And it's definitely, it was a really good class. I don't remember any of it. I've looked at some of my work and it looks like a foreign subject to me now, but it is used, all right? And so typically you take it Calc 1, Calc 2, Calc 3, and the differential equations, just so you know. So remember, a fancy word for differential equation is really just a derivative equation. And so the derivative, it's going to be an expression, and it might involve x and or y, okay? And so what we're going to focus on is which of those are separable. So if they're not separable, we're not going to be doing anything further with those. We really are going to want to classify separable differential equations, separate them so we can integrate them, and our goal is to actually find the original function that produced that derivative. Okay, so that's the idea. All right, and you have done this before when we integrated, except the variables were already separated, so you didn't even realize it. All right, so let's talk about or see some examples of what's separable and what's not separable. So there is a rule. When you separate to get x and y on one side, you want to get all the y terms, like y dy on one side, and you want x's and the dx term on the other. So up until now, we have always thought of dy dx as one quantity, the derivative. And that's true, but it is the derivative of the y function with respect to the x variable. And so because these are written as a fraction, mathematically, we really can separate them with multiplication. The only rule, though, is to move the other variables, you're only allowed to multiply or divide, okay? So you're not allowed to add something from one side to the other if it's connected with the dx, okay? And so there are some things that look a little trickier than others, so obviously we're trying to see if you really understand the difference. So let's say I started out with this function. dy dx equals x times y. So what we can do is we can multiply both sides by that denominator, and we can also divide both sides by y. And so that would give us this, all right? And so see, I can get all the y terms on the left, all the x terms on the right, and that's separable. Same thing here. Let's say we start out with dy over dx equals y squared. Well, we can still multiply by dx to the right and divide by y squared, and so we can separate it. Same thing with trig, okay? Notice, remember, trig needs to be in the trig word, the variable, but dy over dt, you want to get all the y terms on one side because y is the function and t is the variable, so all the t terms on the left side. So multiply, multiply, and we can separate it, all right? Now, what's not separable? Like this. If I multiply by dx, the dx will go on the end, and I can't just subtract y because this is like a whole quantity together. You're not allowed to do that, so that's not separable. Same thing here. I can multiply and multiply, but I get x plus 2y dy equals y minus x dx, and then how do I get those out? Well, you can't. So same thing here. I can't just add this to the other side, so that's not separable. All right. So what does it mean to solve? Because those are going to be your directions. It'll just say solve the differential equation. Well, to solve means to separate your variables, you integrate both sides, and because we don't have an initial condition, typically, you're going to still have that plus c, and then you find the original function. Okay? AP information regarding differential equations. Well, it's both free response and multiple choice. Typically on the free response, they are very picky about the points. On one of your questions, I actually show you one of their rubrics so you can see like, oh, if I don't put a plus C, I can only get 2 out of 5 points. If I don't separate my variables, I can get 0 out of 5 points. They're usually 5 to 6 free response points for just that portion. It doesn't mean that it's hard, but they're just really picky about what they want to see. Okay, so don't think like, oh, I'm just going to skip these points. These are the points you want to get because they're very attainable. All right, as long as you can integrate, you should be fine. You must show the steps where you separate the variables at the very beginning. It seems silly, like, oh, I just do it in my head. Well, no. And most of you will do that anyway, so I'm not super concerned about it. You must also show the step after integrating with the plus C. So if you don't write a plus C and you're just like, oh, yeah, I found it, I forgot to write that, well, they're really picky about that. Okay, so let's do example number 1. The goal, though, is, I should put another check mark here, is you want to get y alone. And so that's where a lot of the math review comes in, and that's actually why I have so many examples for you to see, okay? Because I just think, well, it's good review. All right, so this reviews a lot of Sec 3 that you might not have seen in this class so far because we haven't actually been doing this since y's already been alone on all of our problems. So the first step is I just want you to identify which of these are separable. So this could be multiple choice. This would not be a free response question. I do not want you to solve them though. I just want you to say, yes, I can separate them or no. So the first thing you notice on this one is they wrote it as y prime. I would definitely split that up and write that as dy dx. Okay, it's just a substitution. So I get x over root y. Now you need to figure out is, can I separate these with multiplication and division only? So I say, well, what if I multiply both sides by dx? That's legally allowed because I'm multiplying. And what if I multiply both sides by root y? Well, then I would get root y times dy and x times that dx. And so, yeah, I got them separated. So, yes. All right, this one. Well, remember, natural log, this inside, I can't just divide by the y, so got to get a little creative. Remember, we have log properties. This is the product log property that I've reviewed when we did derivatives and integrals. So if we have a product here, we can rewrite this as the natural log of x plus the natural log of y. Okay, so let's see. Well, I can't subtract, and if I multiply by dx, then I still have that x and the y on the right side. And so, no, even with this property, I can't. Now, there is a log property that does help you, okay? This one, so dy dx. Ooh. Well, that one is actually kind of like the last problem. I can't just subtract y, and so, no, that's a no-go. All right, my last problem is already dy dx. Ooh, I got a trig x, so that has to stay together, and I have y on both terms, and so I think of that one F word you're allowed to say in my class. Factor. So we want to do a common factor. If we take out a y of both terms, I'm left with sine x plus x equals dy dx. Then I can multiply by dx, and I can divide by y. So I have 1 over y equals sine x plus x. These can still stay together. And we don't technically need that parenthesis because we understand in notation they are together. And so I got all the y terms on one side legally with multiplication and division and all the x's. So that is a yes for that one. All right, so get creative if you need to. All right, on my next example, we're going to solve the general differential equation. So what general means is we should have a plus c somewhere in the answer. Now, it is not always at the end, so you have to really be careful. I have 1, 2, 3, 4, 5, 6 examples. I don't know if you need 6, but I did try to pick 6 different types of functions, all right? So if you see a few and you think, yep, I've got this, you can go ahead and fast forward and see the next examples for the particular. All right, so on step 1, we're going to get used to the notation. So step 1 is to show that you separate the variables, separate variables. And you don't have to show the multiplication, but you just need to write the step where they're clearly on each side. So I would multiply by dx on this side, and I would multiply by y on that side. So I would get y dy, and then 2x dx, okay? And so this step is separating the variables, okay? And that allows me to get all 6 points or all 5 points. Step number 2 is you're going to integrate both sides. All right, so we're going to integrate, and I have to kind of talk you through an idea here. So when I integrate on this side, it is a power rule with respect to y. So you get y squared over 2. Now, I'm going to put this here once, okay? There is a constant here. And I'll explain why I'm putting the C1 in a second. On this side, I'm going to do a power rule. So I get 2, and then I get add a power, divide by it. And I also get another plus C here, but it's not the same constant. And so that's why I put a different constant here. Now, once you integrate both sides, your goal, step number 3, is to solve for y. We want to get y alone. So let me introduce an idea. If I want to get y alone, I can subtract this constant. And so my constant 2 minus my constant 1 actually gives me a third constant, right? Well, that's a whole lot of constants to keep track of. And really, if I don't know what any of these constants are, I don't need to keep them all separate. So I'm going to go back here, and whenever I do the y, I don't put my constant of integration on it because I know I'm just going to move it over anyway and combine it. So I only put my constant on the x side of the equation, okay? And that stands for a general constant of the theory. Get it? So we do have a constant with the y when we integrate and a constant on the x when we integrate, and then we get them together and we have a third constant. But really, it's all just one unknown constant, okay? So mathematically, this will not affect anything. Even if I was given a specific point, this would all work out, I promise, okay? So solve for y. So I'm going to say, don't forget the plus c when you integrate both sides, but it goes on the x side. Now, to get y alone, this is a little bit of like voodoo math. Follow with me. But once I explain it on the first problem, the next problems go a lot quicker, all right? So we are going to multiply by 2 because you always want to multiply by the denominator. And remember, when you multiply, we have to multiply everything on that right side. So I would get y squared. These 2's canceled anyway. I just didn't clean it up. So I would distribute that 2, and I would get another 2 back. And then I would have plus, once again, I'm going to write it here, plus 2 times a constant. Well, 2 times a constant is still another constant. So now I'm at my 4th constant. Once again, that whole idea is silly. If it's a 4th constant, we don't need to keep track of them. So we really do just write another constant. Okay? Now, y is not alone. So in order to get y alone, we are going to take the square root of both sides. Now notice my root, that constant, like if this was a 5, that constant would be under that radical. So it's not going to go outside the radical. Okay? And so we get y equals, we took a square root, so technically it's plus and minus 2x squared plus c. Now, because this is being added, I cannot simplify any of this under the radical. So this is my general differential equation. Okay, so big key points. Don't keep track of all the constants. Constants can change. If we needed to find a constant, we would be plugging in a point at some step, and then it would be adjusted. We would be able to pick which of these, if we wanted the positive root or the negative root. Like, that's all coming when we get to particulars. But on general, this is what we need to see, okay? I just think it's unusual to have a constant under a radical, and so students need to be aware that that is important, that you pay attention where things go. All right. Let's go on to number 2. So here's our derivative. We got x times y. So I'm going to go ahead and keep the x. So I'm going to multiply by dx and divide by y. So I write this as 1 over y and then x dx. So that is my variables separated. I don't write dy over y because I know I'm going to integrate this and I just don't like to see it. It's a preference. All right, so that's my separating the variables. Next, we're going to integrate, and you do want to write that integral symbol. So remember, 1 over y, well, that's a special integral, which is natural log. And because we don't have any knowledge about domain, we do need absolute value. And then I get power rule x squared over 2 plus c. All right. So stay with me. So this is going to be a very typical problem, and I'm going to introduce some new ideas to you. So if we want to get y alone, well, I have to get y outside of that log. So you have to remember that natural log is really log base e, okay? And so we can set this up as an exponential equation. I know this is like a blast from the past. This would not be reviewed in calculus. This would be learned in Sec 3. So we get e to this whole exponent is equal to the absolute value of y. Now, technically, y is not alone. And so in order to get rid of y, remember, absolute value means that the other side could have been positive or negative. So I can write this as y equals plus or minus e to this exponent. Now, this is an okay answer. It really is okay. It would get full credit if this was a free response, all right? But if this is multiple choice, or if you're looking in other calc textbooks or online, you're going to see something else. And so I'd be a terrible calc teacher if I didn't introduce you to this idea. And it shows up on this kind of situation. So what if we do some exponent manipulation? So I'm going to have plus or minus here, e. And remember, if I add in the exponent, I really can be multiplying the bases. So I'm going to write this as x squared over 2 times e to that power, which is c. Because remember, if my bases are the same, I add exponents. Okay, you with me? Okay. Stay with me a little longer. Now, what if we, because we're multiplying, I can really put this e to the c in front. Remember, e is a number and c is a number. So this is all just a number. So I get plus or minus e to the c times e to this equals y. Okay? All right, stay with me. One last idea. And so instead, because this looks really just like complicated and kind of messy, what a lot of math books do is they say, you know what, I don't really like that. Let's say A, and we just picked A, and I didn't pick this. This is just what mathematicians have typically done. What if A equals plus or minus e to the c? Okay, and I'm going to say where A equals this. So then I get y equals A e to the x squared over 2. And this is the entire answer. Okay. Now, this is also an alternative. I won't say it's okay or better, because I don't think it's better. It's really not. But if I don't show this to you and you see it, well, then you might be a little confused. So that's where it comes from. And the only reason why they do it is to get rid of that plus and minus in the function, even though they've given this disclaimer. Okay, so these two have to go together. You can't just say, oh, let it be A. I don't know. Mathematicians, I guess, just don't like having plus and minus. They just like it to look a little neater. They like it to look like exponential growth and decay, because that's what the next section is. And so that's where we're kind of leading you, just so you know why. All right, so just kind of be familiar with that idea. All right. Example number 3. Well, there is no x term, so I'm going to go ahead and just multiply by dx and divide by y squared. So I get 1 over y squared equals, I'm just going to put a 1 there. I don't like leaving it blank. So I did separate the variables. All right. So then we're going to integrate both sides. Now, remember, this one to integrate, I don't know how people do that in their head, so I'm just going to rewrite it because it's worth my time. I like to get it right. So, oops, why did I write? I'm already one step ahead of myself. That's a 2. So I'm going to add 1, which is -1, divide by -1. On this side, I integrate 1 with respect to x, and I always get that plus c. Oh, I didn't even talk about the point distribution. That's okay. So, well, I'm going to multiply everything by -1. So, and I'm going to rewrite this. So I get 1 over y equals, because that's y to the -1, negative x, and then I don't change this to a minus c, because remember, c can be any constant, so it could be positive or negative. So I still do write this as a plus c. Does that make sense? All right. So now the idea is, how do I actually get this alone? Well, I can make this a fraction, and then I can just flip both sides. So I get y over 1, which is just y, equals 1 over negative x plus c. No absolute value, no tricky math. This is pretty straightforward. All right. The point distribution, this would probably be 5 points. So let's just go over it on 1. So you would get 1 point if you showed that you separated. You get 1 point if you integrate. So we're going to say right here, so this is my integral. You get 1 point for the plus c. So if you didn't put a plus c, the most you could get is 2 points. They don't even look at anything after. Okay. We get probably 1 point for distributing the negative, and then 1 point for actually getting y by itself. So that's where the 5 points would come in. All right. Same thing here. 1 for separating, 1 for integrating, 1 for the plus and minus, 1 for getting, 2 for getting the y by itself. Oops, I gotta scroll down, sorry. That's where it would go. All right. Okay, so let's try 3 more. Like I said, this might be a lot for you, but if you need a lot of review, then I would definitely watch this. All right, on the next problem, we've got y and t. So they didn't use x, but just think of them as getting them separate. So you have to think, how I've got y and t in the exponent. That's kind of going to be what I did over here with those exponent properties. So you need to rewrite this as dy dt equals e to the y times e to the 2t. Okay, so you will need to separate that. Like I said, I literally don't think, and I know this is 24 minutes in, I don't think it's a waste of your time to watch this review. All right, so we are going to divide by the e to the y. I'm going to make that, I won't skip a step. All right, I'm not going to skip any steps. So 1 over e to the y dy, and then multiply by dt. Okay, now this looks like a quick problem, but it's actually not super quick. On the left side, in order to integrate, I really can't integrate when e is in the denominator. So I am going to rewrite this as e to the negative y. Oh, that's a y. And this side I'm going to leave alone because there's really nothing to do there. Now, on the left side, we need to do a u substitution. Okay, so I'm going to integrate. Okay, but on this, I get u equals the exponent. So du equals -1 dy, so negative du equals dy. And we do need to do u substitution. So I get e to the u, and du is negative du. All right. Now, on the right side, we have to do another u substitution. So u equals 2t, du equals 2 dt, so 1/2 du equals dt. So I get e to the u, and then dt is 1/2 du. All right, now notice, I know I have u's, but they are separate, so keep your left and your right separate in your own mind. All right, so when we integrate e to the u, we just get e to the u. So it's negative e to the u, and I'm going to plug that back in. Same thing here, I get 1/2. E to the u is e to this u plus c. Now, we need to get y by itself, and it is in the exponent. So I'm going to go ahead and divide everything by -1. So e to the negative y equals -1/2. Remember, that just stays a plus c. And then this one's kind of hard. You have two choices. You could either take the log of both sides, or you can rewrite this. So I'm just going to go ahead and choose to rewrite it. So I get 1 over e to the y. And then I get this. Okay. And so same idea, I'm going to make this into a fraction. So then I can flip both of these. Now, I don't think this is easier, but I'm going to write it over here so I can erase it. So I get e to the y equals 1 over this. Now, if this wasn't free multiple choice, then you have a lot more options. If this was multiple choice, I probably might have chosen a different strategy based on what the answers look like, because there is a lot of manipulation. Let me make sure I copied everything right. Okay, and so now we still have y in the exponent. And so at this point, even if I didn't want to take the log before, I do need to take the log of both sides now, because log and e to an exponent, those are inverse operations. So it would have been easier if I did it before, but we're going to take the log of this and the log of all of that. So those cancel, and we get this. Oops, I don't know why I wrote minus. Now, for free response, this is fine. I doubt this would be the answer if it was multiple choice, because we do have log properties. So I'm okay with this, but let me do a little bit more trig review in case it's not algebra review, really. So because these are a quotient, you really can split them up as the log of the numerator minus the log of the denominator. This is asking you e to what power gives you 1? Well, that's 0. So you might just see this, negative natural log of this. And the inside of the log needs to be positive, and so you might see a restriction. And you might see where -1/2 e to the 2t plus c is greater than 0. Okay? Or you might see an absolute value sign, things like that. Okay. But for free response or on a quiz, I'm okay with that purple circle. All right, let's try the next one. So these are together. I'm going to leave the 3 on the right side. So I'm going to go ahead and divide by y. And I'm going to keep the 3, and I'm going to divide by 2 plus x and multiply by dx. Okay? Take a second, make sure you're okay with that. All right, we're going to integrate both sides. So the integral here is the natural log of y in absolute value. This one is technically a u substitution. So if u equals 2 plus x, du equals dx. So I would get, this is dx, I'm sorry, du. This is u. So I would get equals 3 natural log of u plus c. We have some options. I can bring that 3 up as a power. We can leave it alone. It's really a choice. So I'm going to bring the power up. I get natural log of y, and you'll see why in a second. I prefer this. It's going to be 2 plus x cubed. So we need to get y alone. So remember, this is e, and I can change this to exponential. So I get e to this equals absolute value of y. I am going to erase all of this because I need more room. Okay, so using our properties, I can split this up. I'm not allowed to cancel this because of this plus c, so that's why I technically do this every single time to keep it mathematically legal. Now, anytime you have e and natural log right by each other, even if it's in an exponent or right in front, they do cancel out. So we're just left with 2 plus x cubed. And then, once again, I can get rid of those bars by putting a plus or minus in front of this, e to the c, because e is a number, c is a number. And so you might see this written as y equals 2 plus x cubed with an a in front, where a equals plus or minus e to the c. Okay, and so this is probably the best answer. It wouldn't be incorrect if you left it as the step before, though. Okay. All right, one more. I'm going to leave the 3 alone. So I'm going to go ahead and multiply by y squared, multiply by dx. So I get y squared equals, I'm going to write this as x squared plus 2 over 3 dx. All right. To integrate this, I'm actually going to integrate this side. So add a power. So y cubed over 3. On this side, it's probably a little hard to see. So I'm going to rewrite this first. So I'm going to write this, there's like a 1, and I'm going to split them both up over the 3. So I get 1/3 x squared plus 2/3. Okay. So then the left side. So if I integrate, I'm going to add a power and divide by it. So I get x cubed over 3 times 3 would be 9. And then I'm going to add a power of x and then plus c. Okay. So we're going to go ahead and multiply everything by 3. So those cancel. We get y cubed equals, that reduces to be x cubed over 3 plus 2x plus, remember, just another constant. And then the last step is to take the cubed root of all of this. So with the cubed root, we don't have to worry about plus and minus. So we get the cubed root of all of this. And don't worry about a fraction and a root. The AP totally does not care. All right, so I'm going to go ahead and pause this because the next section is, well, actually, never mind. I'll just keep going. So I have 3 problems on particular solutions and then a sketch. All right. So a particular solution is going to be one more step, and it might make the whole process a little easier or a little more difficult. So basically, after you integrate, you're going to substitute the known value to find C. So step 1 is to separate. Step 2 is to integrate. Don't forget your plus C. And step 3 is to use the initial condition to find C. Then you continue on with solve for Y. So I have less examples here because you've kind of seen all the different varieties, but I did try to pick a few different ones. So it's a particular solution because we no longer have that plus C, so we know the exact original function. And there's only one, all right? There's more than one way to write it sometimes, but. All right, so let's look at the first example. We've got dx and dt, so x is the function, t is the variable. We are going to go ahead and keep the x's on the left because dx is on top. So if I rewrote this, it actually would be x over e to the t, because I just get rid of that negative, equals 1. And so this might make it a little easier to see. So I'm going to go ahead and multiply by both of these to the other side. So we get x dx equals e to the t dt. I just think dividing by e to the negative t is a little confusing. You're welcome to do it though. All right, so that's our first step. Then we're going to integrate both sides. So we get x squared over 2. And then remember, e to the t, the integral is e to the t plus c. So x is what we want to get alone. So I'm going to write get x alone. Since we don't have a y here, sometimes it gets confusing. Now at this stage, we've integrated, so now I want to use this condition. So that means that t is our variable, t equals 0, and x equals 1. All right? So t equals 0, and x equals 1. And so we get 1/2 equals, well, e to the 0 is 1. So subtract 1, and so c equals negative 1/2. And that's our constant of integration. So we're going to plug that in back for c. So we get x squared over 2 equals e to the t minus 1/2. And so now when I go to multiply by things, I don't just have a generic constant, and so it will change the value. Okay? All right, so our goal is to get x by itself. So we're going to go ahead and multiply everything by 2. So x squared equals 2e to the t minus 1. We're going to take the square root. And so we get x equals, now technically we get plus and minus. Okay, now you need to pick. Okay, but you do want to show plus and minus on the free response or you lose a point. So we need to pick, it's going to be a positive or a negative that would make this original point true. So if we plugged in 0, which one would give us positive 1? Because that's what it says here. Does that make sense? So if I look down here, if I plug in 0, then I need the positive, so that's the one we want. So we say x equals the positive root. All right, and that's it. All right, let's try the second example. We're going to multiply by y, multiply by dx. So remember, this is x, this is y. All right, now, in order to integrate the right side, I thought this was a good review, we're going to split those up because we can't keep them together. So integrate the left, we get y squared over 2. And then this one, I'm going to go ahead and split up as 1 over x. I'm going to leave that. And then x over x is 1. So notice I haven't integrated, so that integral symbol is still there. So leave this alone. The integral of 1 over x is natural log of x. Keep that absolute value until we can get rid of it. And then the integral of x is 1 is x plus c. Okay? So now we're going to plug in what we know. We know that x is 1 and y is -4. And we can find c. So -4 squared is 16, divided by 2 is 8. The natural log of 1 says e to what power gives you 1? That's 0. So that's something you do need to know. So we would get 1 plus c. I'll even write the 0 there. So c equals 7. Now, at this point, since we know x is 1 and it's on this particular solution, we don't technically need that absolute value anymore. So it's okay if you drop it. So we get y squared over 2 equals natural log of x plus 7. And then our goal is to get y alone. So we're going to multiply everything by 2. They might bring this up as a power. They probably would. And then we're going to take the square root. So y equals plus or minus. I'm going to write this as natural log of x squared plus 2x plus 14. And so we need to pick which one, if I plugged in at 1, would give us -4. So if I plug in 1, I'm going to need the negative. So the natural log of 1 is 0. 2 times 1 is 2. 2 plus 14 is 16. The square root of 16 is 4. So it does work out. So we need y equals the negative. And so if you don't use that log power rule, you'll think it doesn't match up, but it really does. Excellent review. All right, last problem of this type. Now notice, this one has this whole term, and then we're adding the derivative. So this is different than what we saw for the separable part. I can subtract terms, just not parts of terms. So I'm going to go ahead and subtract this yx plus 1. So I'm going to have dy dx equals -yx plus 1. That is allowed because it's an entire term, and then I can see if I can still separate the variables. So I'm going to leave the negative on the right side. I'm going to divide by y, multiply by dx. So 1 over y. We can distribute that. So -x minus 1, and then dx. You want to distribute because we have to integrate anyway. All right. So we'll integrate both sides. This is natural log of y. -x squared over 2 minus x plus c. So we know x is -2, y is 1 for us to substitute. So y is 1, x is -2. So the natural log of 1, once again, is 0. E to what power gives you 1? Let's see, -2 squared is 4. There is a negative on the outside. So 4 divided by 2 is 2, and there's a negative. Remember your order of operations, minus -2. Plus c, those cancel, so c equals 0. That does happen a lot. I just picked one so far that it didn't happen. So then we get the natural log of y is equal to -x squared over 2 minus x. And we want to get y by itself. So another great log review. Remember, natural log is base e, so we're going to set up our exponential equation. E to this power is equal to absolute value of y. If I want to get this alone, it's going to be plus and minus, and I can decide. So based on that point, if I plug in -2, I need to get +1. So we're going to need the positive. So y equals just e to this. Okay. All right, the last one kind of goes through what we did up here. Sorry, it was on the last assignment. It might say to sketch the particular solution on a slope field through specific points. So they gave you the slope field and it said sketch a particular solution that passes through 0, 1. So remember, you're going to use the slope field as a guide. It should hit 0, 1 exactly. And then you want to follow the slopes, okay? You could pick some to go through, but don't go through all of them exactly because it doesn't hit them. So I noticed like these are a little flatter, so I'm going to like kind of go between them and then it gets steeper. Same thing here, it's flatter and then it gets steeper. Okay, and so that's what they would be looking for. This would be 1 point. All right, go ahead and give your homework a try and good luck.